If you thought you know a lot about black hole, you will be surprised after knowing about this recently discovered supermassive black hole. The black hole at the center of a quasar galaxy named J05294351 is guzzling down so much material that it literally eats approximately a sun's worth of gas and dust per day, onto a black hole that already has around 17 billion suns worth of mass. That's the hungriest black hole we've seen yet, according to a team of astronomers led by Christian Wolfe of the Australian National University. And it's expanding so quickly that it's almost at the limit of how much material it can absorb. It's a fascinating laboratory for studying how supermassive black holes grow and evolve at the extreme end of the spectrum. But it's also quite awesome. Supermassive black holes are a mind-bending concept. They're black holes millions to billions of times the mass of the Sun, and they're typically located at the centers of galaxies, the massive gravitational blob around which the entire galaxy revolves. Scientists don't really know how they became that way. Much smaller black holes, a few tens of solar masses, emerge when huge stars' cores collapse directly, and they can grow through collisions with other stellar mass black holes. However, supermassive black holes are just too large for this formation route to be effective, especially early in the universe's existence. There are other possible creation paths, but one method to better understand how supermassive black holes become so huge is to find and study growing ones. This is where quasars like J05294351 enter the picture. These are galaxies with center black holes that eat voraciously. The black hole is at the center of a massive, seething, revolving mass of material that swirls around it, pouring into it like water down a drain. The high friction and gravity lead this material to heat up to billions, if not trillions, of degrees, blazing brightly across space in a spectrum of light. Astronomers can analyze this light, separating it to determine the parameters of the black hole inside. J05294351 is a quasar located in the cosmic noon, around 1.5 billion years after the Big Bang. That's very early in the history of the universe. Its light has traveled for more than 12 billion years to reach us, which makes its massive mass of 17 to 19 billion times the mass of the Sun, which is not the heaviest ever seen, but certainly getting close. And it's difficult to comprehend. However, the rate at which the black hole consumes matter may give light on its enormous size. Wolfe and his team calculated that the black hole is expanding at a rate of approximately 370 solar masses per year. That's a little more than the Sun's mass falling into the black hole each day. Given the black hole's mass, this is very close to what is known as the Eddington limit. This is the highest steady pace at which a black hole may feed. A black hole can momentarily experience super Eddington accretion, but at these rates, the material begins to shine so brightly that the radiation pressure pushes it away from the black hole until it is beyond gravitational reach. That signifies that J05294351's black hole is developing at its maximum rate. Many quasars appear to hold black holes near to Eddington accretion. However, J05294351 stands out. It's the brightest and most voracious supermassive black hole we've seen thus far. In terms of luminosity and likely growth rate, the authors of the study wrote, J05294351 is the most extreme quasar known. There's a lot we don't know about J05294351. The mechanisms underlying its tremendous accretion are unknown. A deeper study with the Atacama Large Millimeter Sub-Millimeter Array in Chile could explain how gas moves around in the galaxy and how it spins. The team also aims to discover other extreme quasars hidden in the far reaches of space and time. Although such extreme examples of these items are uncommon, Wolf and his colleagues believe there are more waiting to be discovered in the vast and fascinating universe.